Okay, so let's do this together now. So again, the data is already sorted for you, right? Okay, so we're going to find the 5-number summary. Now, notice after with it being sorted, we can see the minimum is 1, the maximum is 10. So we have 2 of the 5 numbers already. Okay. There are 16 data values here, right? 16 data values. So let's find the quartiles. We have L, right, is 0.25 times our N. N is the number of data values, which is 16 here. Okay? And of course, 0.25 times 16, direct calculation, that's just 4. That's just what we get. Now, this is a whole number, right? So what does that tell us? That tells us we use the 4th and the 5th data values and take their average. Now, if you count it directly, you would see that the 4th data value is 2. The 5th one is also 2. So they're both the same, so it's easy to see that the average is 2. They're both equal to 2. The 4th and 5th data values are 2. So the average is 2, and the mean is 2, that is, and the first quartile is 2. For the median, same idea, except instead of 0.25, we use 0.50, 0.5 that is. 0.5 times 16, we know is 8. And this is a whole number as well. So we're going to use the 8th and the 9th data values. And what are they? Well, if you went up here and looked, you would have 1. I know it's down here, but let me show you. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So it's 3 and 5, okay? 3 plus 5, right? That's 8. So the average, 8 over 2, is 4. So we get that. For the 3rd quartile, same idea. We use 0.75 though. For 0.75 times 16, that's just 12, okay? Again, this is a whole number. I don't know why I wrote decimal there. I must have left it there by mistake. Let me just cross it out. Okay. But anyway, it's a whole number, okay? So because of that, we use the 12th and 13th data values. And up here, if you count it from the bottom, you would get 9 for both of them. So the average is 9. And Q3 is 9. So this is our 5-number summary. Okay. Now, before we get to the next stuff, let me just show you quickly how you can use Desmos to actually draw the box plot. And from the box plot, you can actually check your work. You know, check if your 5-number summary is correct or not. So let me go to Desmos. Okay. Again, to get the Desmos, what do? Let me start from here. You type in desmos.com. It will bring you here. I mean, I'm already logged in. But you don't have to log in. You could make an account, but you don't have to. You click on Math Tools, Graphing Calculator. Okay. Now, to put our list in, okay, we type in L equals, you're going to use square brackets, not curly brackets. Okay. So we type in our list. Let me get a list here so I can see it. I tried highlighting the list and putting it in. For some reason, Desmos doesn't like that, which is really annoying, but what are you going to do? So we have, there it is. Okay. We have 1, comma, separate, use a comma to separate the data values. 2, 2, 2, 3, 3, 3, 5, 6, 7, 9, 9, 9. 10. So I typed it in. It doesn't matter if it's sorted. I have it sorted already, but I don't think it matters if it's sorted. Then Excuse me, I know it doesn't matter if it's sorted. Then you click below. You type in box plot, parentheses, but you want to put in the data set. So you probably could have typed that data set in directly, but I didn't, so that's okay. I would not click exclude outliers. We don't care about that for now. But this is our box plot. Remember, if we zoom in, let me zoom in like this, okay? Right? Basically, a vertical line, you can click and hold and drag. You can do that. To make this go away, you click the double arrow here. But you can see now our 5-number summary. We have this, let me zoom back in, which is 1. This is Q2, which is 2. This is the minimum. This is Q2. Here's the median, which is 4. Here's Q3, which is 9. The maximum is 10. Q1, Q2, Q3. No, wait. Yeah, that's right. No, excuse me. Minimum. Sorry. Minimum. Q1, Q2, Q3, maximum. So we have, and again, that's what we got, those values. So we were able to check our answer. Okay. Any questions on that? All right, let me get back to the notes then. I know, uh-oh. Let me stop this. Okay, I almost shared my camera screen, my camera by mistake. Clicked the wrong thing. So this should work now. Hopefully they can see it. Good, now they can see it. Okay. Okay, let's see if we have time for this. All right, so I did put this in, I was hoping we could do some of these problems. It doesn't look like we're able to, although we can do maybe one. Basically, again, this is just some of the facts that we had from probability. If you're choosing R out of n possible items, like if you have 20 items or, 52 cards, right, in a standard deck of cards, you want to draw 2 of them, that kind of thing. If order matters and no repetition is allowed, so without replacement, so going back to the deck of cards, the card you draw, you're not putting it back into the deck. Okay? Then the number of ways of choosing R items out of n would be this, permutations. You have this formula. I do know the Desmos calculator you download, you could download that is, uses this notation as well. The book's notation, again, is a little bit different. If it's with replacement, though, then repetition's allowed. Then you just get n to the r. I mean, that should be easy to see. It's just from the counting principle. Now, if order does not matter and you have no repetition, that's where these come in. This is combination. Okay? It's a little bit different. It doesn't matter what order you draw them in. So the example I did was this. So let's suppose you have a standard deck of cards. You want to draw 2 cards, okay? What's the probability of drawing a king and then drawing an ace? So here again, this is what probability is, right? It's the number of favorable outcomes divided by the total number of outcomes. Okay, that's what I'm trying to show here. So maybe divided by, I don't need to have there, but let me just, what the heck, let me cross it out quickly. Come on. Okay. Now, notice order does matter here, right? What does it say? Drawing a king and then drawing an ace. You get the king first, right? That's what they're saying. So order matters here. We're not putting the cards back now, right? They never said we're putting the cards back. Okay? So it's really without replacement. No repetition. Right? So, I mean, it's on the slide already, but remember, order matters, no repetition. That tells you right away we have to use permutations, which is this. Okay, so what favorable outcomes are there? Well, we know there are 4 kings in a deck of cards, right? There's also 4 aces. So by the counting principle, right, there are 4 ways of choosing the king, 4 ways of choosing the ace, an ace that is. So there are 16 possible ways we can choose a king and then choose an ace, right? We multiply with, that's what the counting principle tells us. So there are 16 possible favorable outcomes. You know, if we're drawing a card and then we draw another one. But how many cards are there? How many outcomes are there altogether? So we're drawing 2 cards without repetition. Okay? One at a time. Well, again, it's a permutation, right? That's what this tells us. I mean, you could do a permutation for each of these, but for the king, you would have P of 4, comma 1, P of 4, comma 1 for the ace, but both of those are 4. So we have this. Okay. The number of favorable outcomes divided by the total number of outcomes, right? That's what this is. And if you do the calculation, you end up with this. I reduced it. This is actually from the book. And this, I think what they actually wrote is 1 out of 663, which for some reason I'm not seeing that. I think there's a mistake there in their part, but this is what you can get. On the exam, you don't have to reduce it. You could just write this as a fraction. So, all right, we have like a minute left, so I don't think I have time to do another one, unfortunately. Again, if you need to speak to me, you know, before the final, you know, you can always email me. Office hours, I will announce. I have them today and tomorrow, okay? More than happy to help.